Thank you very much. Hello, everyone. We're going to be talking about decentralizing on-chain access controls, which is to say, how do you have a DAO without giving away the powers to everyone or really using it efficiently? So some quick details about me. By the way, this is like my third or fourth ETH Denver. I'm like losing count now. But I started with Bitcoin in 2012. That's how I got into the space. Started building with Ethereum smart contracts in 2017. And then I joined OpenZeppelin about 2 years ago now, first managing audits on their audit team, and now doing a lot of solutions architecture for our biggest clients like zk, Compound, and several others. And I also do some public policy work on the side in Texas, which is usually around like basically legacy governance, which is always an interesting comparison point to what we do in DAOs today. So OpenZeppelin, you probably heard of it, but our mission is to protect the open economy. We have a leading service for blockchain security audits as well as general advisory. And we also have products that help you to automate and basically provide security on your systems after deployment, some of which we'll talk about at the end of this slide deck. So if anyone's interested in getting more general advisory like what you'll see in this talk, reach out to us afterwards. So what we're talking about here is decentralized access control, and by that I mean allowing the powers to do things like mint new tokens or upgrade the contract or pause particular functionality during an incident. These sorts of things that are very common to many big DAOs today need to be managed carefully. And usually the path to becoming a DAO involves in decentralizing these powers from a small team to a large distributed community, but sometimes that comes with trade-offs. The way that you can actually then make decisions as a DAO is sometimes far less efficient, and that opens up other ways that your DAO starts to suffer as an organization and as a community. So if you can plan ahead and if you can think about how you actually go down that path for progressive decentralization without losing the efficiency, that's really where planning ahead with your access control pays off. So let's talk about some access control primitives that people are using today with our contract library at OpenZeppelin, and then how you can kind of build from there. So Ownable, who in here knows what the Ownable token standard is? Okay, yeah, we got like a third to a half. So this is the basic thing. It's got an EIP. It's well used in our contracts library, and all it says is we're going to specify a single account who's the owner of this contract, and they're going to have special powers that are denoted by the only owner modifier. So then you can basically add that onto any function that is sensitive, and only the owner can call it, and if anyone other than the owner calls it, it just fails. Simple. So for example, I might create a Denver token, and I might then make it so that the owner is the only person who can mint it. So there's a single AOA that now does minting. And this might be like set in the constructor when we first deploy the contract. And so now we have this contract where there's a single EOA that owns it, which is basically a single private key stored somewhere. This is usually the default. You just start with an EOA, but this does come from some risks. If this is like a developer team member, maybe they go rogue, maybe they lose the key and someone else gets access to it. In general, it's not a great place to be long term because it's just such a massive single point of failure. So the next thing that many projects will do is they'll create a multi-sig, usually using Gnosis Safe. And so they'll say, well, instead of just one account, we'll define 5 accounts that have some signing permission on this power, and then we'll say that if 3 out of 5 of them agree and sign on to a transaction, it will be processed. So now we've basically increased our security threshold for a decision from 1 to 3. So now the only scenario we have to be worried about is if 3 of those keys goes rogue or get stolen, not just 1. But that naturally means we have to be careful about what signers we're signing. If we want it to be like somewhat decentralized in the sense of a community could trust it, maybe they all don't work for the same protocol team. There's other community members that are part of the multi-sig, and there's no one entity that can gain a signing threshold. So the next step, let's say, okay, multi-sig is cool, but now we want to go full DAO. We want to make sure that when we actually make a decision, the whole community is approving of it. Well, usually you'll introduce a governor contract, similar to Compound Governor Bravo, or the system that we built for OpenZeppelin, which is essentially a derivative of that with a lot more like extendable features. So we use, like, let's say, OpenZeppelin Governor, and we say basically all the token holders are going to have to submit a proposal, vote on it, and execute it for anything to happen. And the vote threshold is, let's say, a majority vote with like 20% quorum or something like that. So this is great. This is like usually the level of decentralization that a lot of DAO projects try to get to, or let's say claim that they've gotten to with a multi-sig and snapshot. But this is like what Compound did and a lot of other projects have followed suit with. However, it comes with some downsides that a lot of projects usually really don't experience until they've already done it, which is now the fact that all these administrative actions take much longer to perform. So yeah, maybe you want to vote on an upgrade, but maybe voting on like changing parameters or paying your developers on time is now a lot of work. And for example, with a compound proposal, we're talking about a 7-day process, 2-day review, 3 days of vote, and then another 2-day in the time lock waiting for it to execute. So minimum of 7 days to do any administrative action on-chain with Compound, with the sole exception of the pause guardian, which we'll talk about in a second. But this means, like for example, when Compound had an upgrade that went through that caused some issues, when they wanted to put through another upgrade to change it, it took another 7 days. So they had to wait 7 days to fix a bug in production, which is never fun. So, general trade-offs, EOA owner, it's very efficient, it's very fast, you can do things quickly, but you have centralized control, and that undermines some of the security and decentralization. DAO owner, high threshold for trying to get anything done, which gives you a lot of security and decentralization, but it takes a slow time to do things, and some things need to be done quickly or just more efficiently. So this is where role-based access control starts to really break things down and make life easier. So first, let's talk a little bit more about upgrade risks. I already mentioned it a couple times, but when I'm talking about upgrades, who here knows what a smart contract upgradability is with like a proxy? Okay, yeah, we're like doing about half again. So for those of you who don't know, it's basically a way to circumvent the traditional immutability of a smart contract. Normally, you deploy a smart contract on Ethereum, and it's going to be exactly the way it was first deployed until the end of time. But if you want to change it and you want to upgrade functionality or you want to fix bugs, what you need to do is create a proxy pattern. There's other upgrade patterns, but the proxy pattern is most common. It's what we have some libraries for at OpenZeppelin. And basically, you just put in all your logic into a separate contract, and then you can swap it out at any time. So this is great for being able to basically change your functionality without forcing your users to migrate to a new contract, but it does introduce risks. Now you have to worry about upgrades being safe. If you do an even minor upgrade, that could cause issues. You also have to worry about being integrated with other protocols that are upgradable. So I integrate with another protocol that's upgradable. I depend on their functionality to be a certain set of interfaces, and then if they change that and I'm not prepared for it, well, that could break my protocol. So so with great power comes great responsibility is essentially what I say about upgradability. So let's define powers separately now. Let's say we want to add, in addition to mint, we'll add 2 new powers to our smart contract. We'll say there's an ability to pause and stop all smart contract operations and freeze it. And then we'll have upgrade, which allows us to, of course, change the functionality of the smart contract, which is very powerful. We need to be careful with it. So with Ownable, we want to have different decision makers for each of these 3 powers now. And we don't have that flexibility because we just set one executive admin and that's it. So what we can do is use role-based access control with the OpenZeppelin library to define separate roles. So by default, if you use the library through our contract wizard, you will typically have a default admin that's able to assign the powers for all the roles, and then the specific roles themselves. And they'll all have their own modifier, where you just say only role, and then you put in whatever the constant is for the role, like pauser role, upgrader role, admin. Now we can decide what kind of decision maker we want for each role. So let's bring back in our DAO, and let's say, well, we want the DAO to have powers to both basically set the roles. So it's going to be the default admin. It will decide what all the powers are and who gets them. And it will also be the sole authority on upgrades, because we do want to have a high threshold for that in this particular case. So we have an important check on powers that can break immutability. But pausing, well, that's important for security scenarios. And we would like to have an entity that can move quicker than a DAO that might have a 7-day period. So let's choose a multi-sig. So a multi-sig can be set up. They can pause the contracts. And this is good because we do, pausing the contracts does have a big impact on a protocol in terms of their availability. So we don't want to just give it to anyone. We don't want it to be someone who's trigger happy or maybe can still use pausing maliciously to pause functionality to take advantage of something in the market. So this is an important power. We have to handle it carefully. But if we have to pause something quickly, we do have to get 3 out of 5 people together to sign a transaction very, very rapidly. And with crypto, we could be in different time zones. Some of us might not be be on speed dial. So especially if you have not planned around incident response in your multi-sig, this is a big point of contention because you really have to be able to move quickly in some scenarios for pausing, and a multi-sig might add quite a bit of time on that, even though it's much better than a DAO. So how can we keep the multi-sig in charge of this pause power but move faster? This is where delegating EOA pausing powers becomes really important. And this is something that you can do today with Gnosis Zodiac, but there's other tools that people are working on, including at OpenZeppelin, to improve on this. But basically what you can do is using Gnosis Safe, if you've already set that up as your multisig, you can define a module that delegates the power of the multisig to another account. And through that, you can then say, okay, normally we have to go through the multisig to call all these functions, but we're going to say for this specific function, we're going to allow this EOA to do so. And that power is controlled by the multisig. So the multisig can set the EOA to be a pauser, and it can remove the power for it to be a pauser. So now we have the ability to say, okay, this EOA is controlled by either whoever the developer is on call, or maybe even an automated bot that can rapidly fire a pause in response to seeing something on chain that we know is going to be an issue that we have to stop the protocol for. So using Gnosis Zodiac and using Governor and using RBAC, we can set up a system where now we have the fastest response time possible, but we still have a good level of decentralization in how that power is managed. So there's a spectrum of access control we've built out. We have the DAO, which is super decentralized, awesome. We've got a big check on power. We feel like everyone has a say. Upgrades and who gets the roles are the things we want to take our time with and be sure that we do appropriately. But when it comes to pausing, we want to set up a multisig where the people on that multisig know what they're doing, they're trained, they have an incident response policy in place, and ideally, they're trustworthy members of the community. The Security Council is something that a lot of protocols use, like ZK Sync Lite, in order to control upgraded powers and potentially go around time locks. And then for that multisig can decide we'll either set one of our signers in a separate EOA or some automation that can then do pausing powers, and we, the multisig, can revoke that power at any time if we think it's being used inappropriately. So the worst that might happen is the EOA goes ahead and pauses the protocol, and the multisig says, no, you shouldn't have done that, we're going to unpause it, and we're going to take away your power. So even though there are still obviously some areas where you would want to be careful about how that pauser EOA is used, you still obviously do not want to lose it, you don't want to have to worry about someone going rogue, but the amount of impact, the damage that can do to a protocol is much more minimal. So looking at this broadly, like thinking about like how are you layering your on-chain governance, the best way to think about it is if you want decentralization, that's where you build on a highly decentralized platform like Ethereum or other networks that have that level of credibility and censorship resistance. And on top of that, we want to build a set of immutable smart contracts. For example, maybe our token isn't upgradable because that's an important primitive in our ecosystem. And other immutable smart contracts, like Uniswap, for example. But we still have some smart contracts that we have to manage through a DAO that are upgradable. And then from there are certain powers of that DAO that we will let a multi-sig council handle, full of people who are more prepared to make those decisions. They're either better subject matter experts, or they're just able to make more decisions more frequently, more efficiently. And then from there, we can delegate specific powers to certain operational units. So as an example, the way we work with Compound today, they're built on Ethereum. They have an immutable token that can't be upgraded. It can't have its token supply changed, which is important because that is the same token used to govern the DAO. And then the DAO controls all the markets. It itself has, like we saw earlier, about a 7-day period for making decisions. But then it designates other entities. It has a pause guardian, a multisig that can pause a protocol rapidly, and a grant committee, which does some of the treasury functions of funding community projects, so we don't have to have a DAO vote just so someone can get like a 20K grant. We can move more efficiently there. And then finally, we find specific things that we delegate to specific units that either get paid or have a relationship with the DAO. So Compound Labs still does a lot of protocol development, but has no direct on-chain powers. Gauntlet does financial risk management for the protocol, and then OpenZeppelin does security audits on a lot of the proposals that go through the DAO, and we get paid through the DAO for that service as well. So with the time we have left, I'm going to tell you a little bit more about how you actually practically build this stuff with the OpenZeppelin tool stack. So the first thing is, of course, OpenZeppelin contracts is a big building base for a lot of these projects. ENS, for example, uses OpenZeppelin Governor and a lot of our other base contracts to build out their ecosystem. So Ownable and RBAC access control that we just saw, that's a big part of our contract library. And if you use the contract wizard, you can actually take some of our standard contracts, ERC20, 721, a 1155 governor, or even just a custom contract as a base, and add in your access control powers, add in upgradability, even create a DAO. And so a lot of this gives you a good starting point. And you can open it in Remix, deploy it, play around with it, and then once you're ready to go big, you can actually then take it and just extend it for whatever additional functionality you need to add. So on top of this, another thing that people actually don't know about us as much is our security platform, Defender. So Defender is there for your post-deployment environment. Like once you've deployed the contracts, how do you manage them effectively? So for example, admin is a great way to interface with Gnosis Safe and other approvals of actions on chain. So for example, a developer team that is not a signer is able to actually propose something that a multi-sig should sign, and then you have an interface through which you can actually approve it and like see all the details of what's going to happen, as well as like set access control and other things. You have Relayer, you can do secure hosted key storage and be able to sign transactions rapidly. This is actually what a lot of our clients use to be able to have pause powers at the ready. So a Relayer EOA would be the perfect thing to delegate powers to. It's custodied in AWS, it's perfectly safe, but worst case, if you don't trust AWS, you have a multi-sig that power can be returned to. And then auto tasks, which are basically just automation in JavaScript. You can do anything with an auto task, including send transactions through Relayer, or you can trigger them from Sentinels, which does a lot of on-chain monitoring. And then finally, we have Advisor, which is just a collection of security best practices. So what we've been actually doing a lot of here at ETH Denver is we have been promoting our serverless templates. So serverless, for those of you, do any of you do like cloud programming that know about serverless? Yeah, okay, a few people here, yeah. So serverless is something where you can configure your entire stack in YAML for your cloud configuration, so your typical infrastructure as code approach. We've extended that and made it a plugin for Defender, so you can configure your entire Defender stack in YAML, as well as all your auto tasks and other things. So you can very quickly either define your stack and have a good version controlled way of updating it and maintaining it, or you could take existing templates and pop them into your Defender account and very quickly have a comprehensive multi-sig monitor, governance monitor, pause powers set up in your Relayer, things like that. So to get started, you can just sign up for a free account on Defender. And by the way, we have a bounty program. We're offering over 10K in prizes. So all you have to do is use Defender in your project in some way and tell us how you used it, and you're eligible for over 10K in prizes. And if you don't know how to get started with Defender, we have these pre-built templates using serverless where you can just basically go in the CLI, tweak a few parameters. Like say, for the multi-sig monitor, all you have to do is say what address do you want us to monitor and what network, and then the rest of it's just inputting your API key, hitting deploy in the CLI, and you're good to go. And we have more advanced things like being able to migrate tokens in a smart contract quickly to another contract, obviously pausing powers, deploying from the contract wizard is another one. And we have a README instruction set that also gives you a lot of details on how to get started. So thank you and happy hacking. That's 10 seconds. So if you have any more questions, I'll be off to the side for a second. But you can also come see us at the booth. We're way over in the Sporkwell Lounge to talk to other open